right, page 3, standard normal distribution. Standard normal distribution has a Z on the side. The shaded area is also 1 or 100%. But notice that the Z-scores are actually standard deviation scores. So the mean on the x-axis is actually translates to a 0 in a z-axis, okay? So these are called standard normal distributions. They've been standardized, okay? Properties of a standard normal distribution, or z-score, is the mean is 0. The cumulative area under is 0.5. That means from here to here is 0.5. From here to here is 0.5, right? Standard deviation is 1. That means it goes up by 1s. The cumulative area that is close to 0 for the z-score. Look at the scale on the end here. Right about here, they're saying it sort of goes to negative, kind of 3.5, kind of. This goes to about positive 3.5. Let's see. Cumulative area close to 1 is at these halves. All right, so any raw, this is the important part, any raw score can be transformed into a z-score or standard score by the following formula. You take your one in particular value and subtract the mean over the standard deviation. So these would be the population symbols. You can also refer to the sample as well to get a z-score. Okay, so let's look at a couple examples here. We have Tina taking a history test and taking a biology test. I'm going to kind of put these two axes together. Okay, so on a z, this is always 0. On an x, this is always the mean. So the history, the mean was 70. The biology, the mean was also 70. So that goes there. Okay. 1, 2, 3 standard deviations over on each corresponds to x values on each scale. Okay, so let's look at the history test first. It says the class mean was 70 and the standard deviation was 10. So 1 standard deviation owes 70 plus 10 is 80, 90, 100 for 3 standard deviations on the high side, 60, 50, 40 for the low side. All right, and her score was an 80, so she scored right there. So her individual value, or x, was 80. The mu for the class was 70. That means everybody in the class's grades, okay? Corresponds, an 80 corresponds to a 1 exactly on the scale. So you can see it pictorially, or you can actually do the math for that. So the 1 score she got was 80. You subtract from that the mean of the class divided by the standard deviation of the class. You're going to get 10 over 10, or 1, which is verified by the picture. Okay, the biology test, she received a 75. Well, the mean for the biology test was 2.5. So this is 2.5, 75, 7.5. All right, and if she got a 75, she's up here, which is 2 standard deviations away. I'm going to verify that with 75 minus 70 over 2.5. So that's going to be 5 over 2.5, so z equals 2. Which test did she do better? She did better on the biology test, which looks harder, right? Because look at this, 99.7 of the class got a 77.5 or less. So she did comparatively well, better with a higher z-score tells you better. okay? Then we can also take that z-score and convert back the other way with this formula here, okay? This is our usual one we just used, and if you kind of manipulate that around, you're going to get this. So we can actually go from a z-score back to an x4. So this is x to a z, this is z to an x, okay? So a veterinarian weighs cats. Alrighty, and you'll see me flip this around. Sometimes I do the z on top, sometimes the x. Make sure the z is always 0. The mean is, where is it, 9 pounds. Okay, standard deviation of 2. So at 1 standard deviation, there is an 11. At 2 standard deviations, 13. 3 standard deviations is 15. It's a heavy cat. Go back the other way, we're subtracting 2. So the z-score scale is always the same, referred to as standard deviations, one at a time, counting out. And the mean changes all the time, and the standard deviation needs to be changed. So let's see, 2 would be 5, over here would be 3. All right, so I've set up my distribution, and I want to finish reading the question here. It says, okay, here are the given z-scores. Find their weights. So let's look at the 0 real quick. If one cat had a z-score of 0, that's the same thing as saying their individual weight was 9 pounds. Okay? 1.96, that's way up here. That's a heavy cat. It's a z-score of 1.96 is my z-score. What does that translate right here? It looks like it's going to be kind of close to 13, on the downside of 13, but let's use this formula up here and say x equals mu, which is 9, plus z, which is 1.96, times the standard deviation. That math is going to come out to 12.92, which jives kind of with our picture here. How about negative 44? That's kind of in here somewhere. This was, I can't fit 12.92 is in there. So they want to know this one, if z equals a negative 0.44. So x equals mu, which is 9, plus z, which is negative 0.44, times 2. X, we expect it to come out to be around 8 pounds. When I crunch this out, this comes out to 8.12 pounds. Okay, so this is valuable to keep handy. X to z, z to x. Okay.